So let's start by creating a sphere. I'm going to change it to polygon and up the frequency here. Now I want to slice the sphere horizontally, and I can do that using a Voronoi fracture. So the Voronoi fracture uses points to split the geometry into parts. Usually, we use a scatter. So we got this pattern here, right? And then we just split the geometry into bits. But because it uses points, we can use any point, right? So first, let me just turn off this interior surfaces, which I don't need. So what I'm gonna do is use a line. So if I plug in the line here, I'm gonna delete this explode view and just like change the lengths. You can see if I template the curve, you can see the curve. It's just there in the middle. So the curve only has 2 points. It's hard to see, but it's just there. Because the curve only has 2 points, it's just splitting the sphere in half. But if I add more points, we start getting this similar to what we want, right? So I actually want the curve to be on the X direction, so I'm gonna change this. And I also want the curve to be in the center. So I can just come here and just move it to the center. But what I actually want is that when I change this length, I want to keep the curve in the center. So what I'm going to do is copy this value and paste relative here, and now divide by -2. And now when I change the length, the curve is always in the center. Okay, so 7 points is good, and I think we have what we need here. So now let's just simulate this by creating a cloth constraint and creating a vellum solver. I don't need gravity, so I'm going to put this to 0. And if I play this, nothing happens. So I need to add some forces. So a pop wind. And just up the amplitude a tiny bit. So now if I play this, we get the error because this Voronoi fracture automatically connected its constraints to the cloth, and I really don't want that. This is kind of, I guess, prepared for rigid bodies, so we don't need that. So we have some interesting simulation here, but as you can see, first the points are detached, right? So we don't want that. We want to create, we want to stitch these parts together and create that effect of the cloth pulling into the stitching. But we can see that there are a few problems already here. So you can see that these triangles, really small triangles, are creating a few issues, and we really don't want that. And so when we start doing the stitching, we will have a few problems. We need a clean edge, and the reason this is happening is because the Voronoi fracture cuts through the polygons, right? So it doesn't go around the polygons or along the polygons, it just cuts through them and creates those small triangles there. So we need to find a way to fix that. So the way I found that I like is using a fracture, edge fracture. And the edge fracture is similar to the Voronoi fracture. But what it does is, okay, I need to refresh my view. So if I go to my labs menu here, I can reset the viewport. Okay, so if I turn on this piece attribute and visualize it, you can see that the Voronoi or the edge fracture is cutting it in parts also, but it's cutting along the edges, and that's what we want. But I can't plug in just the line here because, you know, it doesn't use points to cut the geometry. It uses curves. As you can see here, on the bottom of the screen there is saying fracture curves. So we need curves, right? And yes, this line is a curve, but if I turn off this, it doesn't do much because, you know, I guess it needs to be a closed curve. So for example, if I add a circle, you'll see that the circle is cutting this geometry, right? I was just trying to rotate this so you can see that it cuts the geometry. That's exactly what we want, but we want to keep using this Voronoi because I like this setup. So we need to come up with a way to convert these slices or the curves or these edges into curves, right? So we can use a divide. I actually don't use this divide for anything else, at least not yet. I don't really know why I would, but there's an option here, remove shared edges, that just removes all the edges that are shared and just leaves the other ones. And the other ones are the ones that were kind of created with this Voronoi fracture. So this is what we want, and now we just want to convert those edges to curve. And yeah, here we go. We have the curves that we needed, and now we just need to plug it in here, and we have kind of what we want, right? So one thing that we can do is up the resampling accuracy here, and I think 1 is enough, maybe 2. And this looks weird, but it's fine for what we want to do. We just want to have proper triangles when we stitch this. So let's plug in this here, and we can up the resolution a bit. So we can actually try and see if the remesh works better. Let's see. It's basically the same. So we don't need to use it. I'm gonna keep using this. Okay, so I think this is fine, maybe 40. So now if we simulate, you know, we'll have the same thing, so that all they fall apart. So we need to weld them, right? So we're going to create another Vellum constraint to weld them. So all the constraints in Vellum are the same. So if I create this is the same as the cloth, just with different settings, right? So the constraint type is different, and the settings here are different, but they are the same node. So what I want is to select the weld points, and I don't need to do anything else here because the weld just keeps the points together, which is what we want. I'm just going to change a setting here on the cloth. If I set the mask to set uniform, I get a bit more detail on the cloth, so I prefer this. And also I want to up the radius of the sphere to 1. And now I will have to change the line here. Okay, so cool. Now, next step is to create the stitching effect. And so the idea is to select these edges from the boundaries, then create a group of it, and then expand the group to these edges here, and create another Vellum constraint that just pulls that together. So kind of changes the distance of those constraints. Because when we work with Vellum and create these constraints, it's actually what it's doing is creating constraints. So it's creating some springs, let's say, on each edge that stretch or bend depending on the settings we have here, right? Or do other stuff too. So what we want to do is to change the length of these edges here so we can have that pinching effect. So let's do that. So to select these edges here, we can actually create a group and choose include by edges and choose unshared edges. So if we change this to edges, it will select the edges that are not shared, because they are not connected, these edges. So then we want to expand this selection. So we create a group expand. Before that, let's rename this. So I'm going to rename this to seams. And because I have this $OS here on the name, the group name gets the name of the node. So both are called seams. I'm going to do the same with the group expand. I want this to get the name of the node. So it will be called stitches. I think that's how we spell it. And I'm going to do this based on the seams group. So now I have a control which I can use to expand my group. And this is good like this. Yeah, this is perfect. Let me just try to resample this less, actually. Okay, so I don't have as many overlapping things here, but this is all good. It doesn't look like, but it will work perfectly. So now I have a group called stitches of those edges that I want to pinch, and just to do that, I'm just going to create a constraint, and I'm going to use the default constraint type, but I'm going to lower the rest length scale. So this just tells what size are the constraints. So if I put 0, 0, 1, so they will be really small, so it will pull these edges towards each other, right? So if I just play this, you can see that this is not working like we want. And the reason is because here in the constraints, I have to say which group I want to use. So I want to use the stitches group. So to use this group, I want to apply those constraints only there, right? So if you see, they're only there now. So now you can see that we have the effects we want. But one problem is that there's no pressure, so it just collapses. So let's create another constraint. And let's select the pressure setting, and maybe, okay, let's leave it by default so you can see what happens. So now it keeps the geometry from collapsing. So it creates this set of weird constraints here. So we need less pressure, right? So we need to lower the stiffness, and I know that around 1000 it's kind of okay. I still want a bit more pressure, I guess, so I'm gonna up this to 1.5. Okay, so we have what we want. Okay, so one thing that I want to do here is to give this a bit more of an interesting shape. What I can do is to add a mountain node here. So I can just change the curves a bit and maybe make the element size bigger, and just I don't want any roughness. So let's see what we're getting. I think this is a bit more interesting. I might offset this a bit. We need to be careful not to create like really small bits, but I think these ones are fine. Let's see how this looks when we simulate it. Okay, that's actually interesting. So let's organize this a bit. Let's give it a color. I'm gonna go with green for this guy. And I'm gonna put it inside of a network box and give it like a darker green. So this one is called cloth. We want to have some points where we can scatter some lines. This edge fracture creates some points, creates like some new points when it fractures the geometry, and we're gonna use those. So let's create a line. Copy 2 points and connect these guys here. And okay, now it's of course using the full geometry, but I want to change the target points to new points. And so let me just go back to the first frame and just use the new points. Okay. So now the problem here is that the line doesn't have the right direction, so it needs to be pointing to Z, and it's a bit too big, so let's do like 0.5, and then we can change the scale with the noise. So okay, looks like almost everything is okay. The only problem here is that we have a few lines sharing the same point, or actually there are a few points overlapped because of this mountain that we used. So the curves are overlapping, and this will mess up our simulation because it will only attach one point and all the other points will fly away. So we need to figure out how to solve this. So I just used a fuse here. And chose the new points. So it just fused all those points together. So we don't have those lines on top of each other anymore. Okay, so now, of course, we need to also simulate those strings, right? Because they are not attached. If I simulate this, they just stay there static. So to do that, we know that we want them to behave like hair. So there's also a string setting. I can show you here. I could just select string, but I find the hair works better. So now they have like a hair constraint. They are basically hair, but the thing is that I need to simulate them, so I can't have two solvers. I need to somehow make all of this constraints work together, and so the way I prefer to do that is with a Vellum pack. So we need to merge them basically. We could use just some merge nodes. I see that often on tutorials. But I actually prefer to use the Vellum pack node. So I just pack them here. Also pack these guys. I'm gonna disconnect the solver. And then I merge them. And then I unpack. This way it looks like it works better for me. So, and it's kind of neatly arranged. So yeah. So now, yes, they are all working together. But I need to tell Vellum which constraints use which geometry. So, or which where will I put the constraints, right? The same way I did here with this distance, because here I said, okay, I just want to put the distance constraints on the stitches group. I need to do the same with all the other ones. So I need to create a group for my hair, or my strings. So that group will be called strings group. And I need to create a group for the cloth group. And these can be primitives. And now I think they can be primitives, yeah. So, and then here on the Vellum hair, I will choose, actually, yeah, I will choose which group I want to add these constraints to. And here the same, so cloth group, so the weld and the cloth, the distance is on the stitches there, and the pressure is on the cloth, because I don't want everything to be the same material, right? Or have the same constraints. So now if I play this, we can see that some things are happening, not exactly what we want. And there are a few reasons for that. First, I need to glue the hairs to the points of the cloth object. And then I need to add more points because the hair only has 2 points. So to do that, I'm going to go and add a few points here. Actually, I'm going to use a resample. And 2 points. And now the resample might be better for this because I can choose the subdivision curve, so it kind of rounds them a bit more. And 0.01. And yeah, I think this will work. So, of course, nothing will happen yet because they are not glued. And the hair is still a bit stiff, so I'm going to lower the bend constraints. Yeah. Still a bit. Okay, it looks okay now. Next, we need to glue those hairs to the cloth main object. And to do that, we need to do a few things. First, we need to define the base point on the curve or on the hair where we want the hair to be glued to the main object. So we need to create a group here. We need to create a group at the base of the hair. So I think I have this template. Yeah. Okay. So to do that, it's pretty easy. We just use a group expression. And it has a few presets, and one of the presets just finds or creates a group with the first point of the primitive. So if I choose this and change this to points, I mean, you'll see that it just selected this first point. So we have our group called, I'm gonna put OS here, and I'm gonna call this hairpin. So then I will need to decide which points I want to use here for these pins to be glued to, and again I'm going to use the same ones, the new points, the ones I used to copy the lines into, right? So let's add a glue constraint. I will need to add the let me just turn this on. I need to use the hairpin here, and then I need to use the new points here. And now it will create a few constraints, as you can see here on the base. It also constrains the hairs between themselves. So I need to, if I lower the search distance, it doesn't do that anymore. And I can fix that also in a different way, but even if they are glued together, it's fine. I know it doesn't matter that much. So if I just play this, you can see that now they are going with the object, right? And maybe, you know, we need to change the band stiffness of the hair a bit. Okay, maybe a bit lower. Yeah, and I think it looks okay. Now we have our strings working. So let's just create a simple color here and just organize this a bit. Okay, so don't forget to save. Now I want to create some little spheres like beads at the end of those strings there. And I could definitely go and create another copy to points, create another, try to simulate them together. That's what I mean. And it's a bit more involved. And I will definitely create a tutorial on that. But I think no, we don't need it now, because we don't need those spheres to actually collide properly with the cloth in a sense that they will deform the cloth. So we can actually create them after. So we can create them here after the solver. So let's just do that. So to be able to copy those spheres into those points, I will need also a group of those points there at the tip, right? So I'm gonna do that here, and the way I can create that is using group by range. Maybe I should do this after the resample actually. So I want just to put this on one and invert the selection. So I just select that one, and I'm gonna call it here tip. So now I should have that point here, and now you'll be able to create a copy to points. Actually, this is wrong. Create a sphere. Just leave the sphere there. And I think the sphere is too big, or it's creating on all the points. See, it's creating a sphere on every point. So I just need to say I only want on the hair tip. And the spheres are pretty small, so let's just put this to 1. And then we can add, yeah, let's set a P scale here. And now just scale them a bit. I will keep them all the same size. One thing that I also want to do is to change the size of the hair. I'm going to create attribute noise on the P scale. And so I can create like a, not a random, but something more like this, almost random. And I'm going to add min max, so I can change the, I have more control here. So they are almost the same size, but not all of them. And so, yeah, I think it's fine like this. Let me simulate this a bit. Okay, it looks nice. And now I will have the spheres there, so I can actually merge just to visualize them. Yeah, I can actually scale them down a bit more. Yeah, so next step is actually to give this another color. I like to color code stuff, makes it easier than down the line. So beads. Save it. Okay, so we are almost there with our simulation. One thing that I want to do is I kind of want the object to be floating, but I want this strings to be actually affected by gravity. But that's not happening because the pop wind is affecting everything. So I don't want the pop wind to affect, or I only want the point, the pop wind to affect the cloth. So let's see how we can do that. So I have a few groups here. I have new points. I don't want that hair, no. But I have the original points. That could work, right? Because it only gets points, right? It's only because it's a pop wind. It's only looking for points. So I can use those. Those original points refer to the sphere because they are created by this fracture, so it's the original points before the fracture. I could do that. I also have this cloth group, but it's primitives, so I might actually, use this cloth group. Let me think a bit. I could use those original points. Also, I guess I'm gonna create a group of the cloth. Yeah, a point group. So let's create it here, and I can do this like cloth points group. That's it. And I'm gonna create one also for the hair. Actually, I don't need for the hair. Yeah, I don't need it, because what I can do is I can say that this pop wind only affects, let's see, I need to go back. Okay, so this only affects the pop wind, the pop wind only affects the cloth. So now, the hair is moving, but it's just being pulled. It's not affected by the pop wind. So now I want some gravity only on the hair. So what I can do is also use a pop force, and change this to 9.8, and say, okay, use it on everything but the cloth points group. So this exclamation point just negates that. So now the hair just falls, affected by gravity. So that's it. So this is the main structure of our object and our simulation. So next we're gonna do some adjustments here, and after we'll jump into lighting and shading.